Hi everyone, in this video we look at a problem where we're told the fourth term of the geometric sequence is 135 over 8 and the eighth term is 10,935 over 128, and it says to determine a formula for the nth term and to determine the first three terms of the sequence. So let's go ahead and we'll try this problem. So we know that for a geometric sequence, we know that the nth term can be written as a, which is the first term, times the common ratio to the power of n minus 1. So if we, what we know is that the fourth term of the geometric sequence is 135 over 8. So we have that t sub 4 is 135 over 8. Which is equivalent to, well, we have, let's see here. We have that t sub 4 is 135 over 8. And that's equivalent to a times r to the power of 4 minus 1. Which is just, we can just write 4 minus 1 as 3. So this is, t sub 4 is ar to the power of 3. T sub 8, we're told in this problem, is 10,935 divided by 128. And that's equal to AR to the power of 8 minus 1, which is 7. Okay, so this is the information that we're given in this problem, and in order to figure out what the nth term is, we have to solve for a and we have to solve for r. So how do we do that? Well, if you think about it here, we've got two equations. We've got this equation where we have 135 over 8 is equal to AR to the power of 3, and then we've got 10,035 over 128 is AR to the power of 7. Now, notice what happens is if I divide t sub 8 by if I divide the eighth term by the fourth term, I have that the eighth term divided by the fourth term is going to be AR to the power of 7 divided by AR to the power of 3. And this has to be equivalent to, well, 10,935 divided by 128, or over 128, divided by 135 over 8. So notice what happens when we divide the eighth term by the fourth term is the first terms divide out, and I have r to the power of 7 divided by r to the power of 3, which is just r to the power of 4, because when we divide powers of the same base, we subtract their exponents, and 7 minus 3 is 4. So we've divided out 3 factors of r. I can clean up the right side of the equation a little bit by simplifying. I can write division by a fraction as multiplication by the reciprocal. So I can write this as, instead of dividing by 135 over 8, this is that's the same thing as multiplying by the reciprocal, which is 8 over 135. So we have that r to the power of 4 is equal to, well, let's see here. Let's see if we can do some dividing. So 10,935, if we divide that by 135, that is equivalent to 81. And 8 goes into 128 16 times. So we get to that r to the power of 4 is equal to 81 over 16. Now, we got to be careful when we do this problem. So we have that there's two solutions for r if we take the fourth root of both sides of the equations. We get that r could be equal to the fourth root of the positive fourth root of 81 over 16, or the negative fourth root of 81 over 16. So we get that r is actually could be plus or minus 3/2. Okay, so and we're going to see why we can have that being true in a second. So now we're left with solving for a. I know that t sub 4, or the fourth term, is equal to 135 over 8, which is equal to a times plus or minus 3 over 2 to the power of 4. Or sorry, whoops. We have that the fourth term, we're going to be raising it to the exponent n minus 1, which is 3. So we have 4 to the power of 4 minus 1, which is 3. So we have that a is equivalent to, well, let's see here, plus or minus 3 over 2. When you raise it to the power of 3, if it's negative, it's going to be it's going to be a negative number, and if it's positive, it's the cube root of, or sorry, the cube of a positive number is going to be positive. So we have that we have two solutions for a. A is going to be equal to, well, let's actually calculate what the cube of 3 over 2 is. So if I cube 3 over 2, let's see here. So 3 cubed is 27. 2 cubed is 28. So I have that plus or minus, 3 cubed is just 8. So I have plus or minus 27 over 8 is equal to 135 over 8. And so, let's see here. Well, I can multiply both sides of this equation by 8. And if I do that, those 8s divide out. So I get that plus or minus 27a is equal to 135. So a is equal to plus or minus 135 over 27. And if we divide 135 by 27, we get 5. So a is equal to plus or minus 5. Now let's think about this for a second. Because if a is positive 5, that means that r has to be, that means that r is positive 5 as well. If a is negative 5, that means that r is negative 5 as well, because they have to have the same sign here. So I have that t sub n is equal to 5 times r, which is 3 halves, to the power of n minus 1, or t sub n is equal to negative 5 times negative 3 halves to the power of n minus 1. And the reason that I have two possible solutions here is because both of these solutions satisfy the information that I'm given in the problem. That is, if I raise, if I substitute 4 for n, I'll get the term of 135 over 8. If I substitute 8 for n, I'll get a positive value as well. So either of these solutions are correct. In the next part of this problem, we're asked to figure out what the first 3 terms are. So we have that t sub 1, and we've actually got 2 solutions for the first 3 terms. So we've got a positive and a negative solution. So t sub 1 is going to be equivalent to, let's see, 5 times 3 halves to the power of 1 minus 1, which is just equal to 5. And that's no surprise because we already solved for a. We've already got the first term, so really we didn't need to do this. But it's just goes to show that our formula is correct. Now, because a could be plus or minus 5, it's important to note that t sub 1 could be plus or minus 5. We have that t sub 2 is equivalent to 5 times 3 halves to the power of 2 minus 1. And that's using the positive value for a and the positive value for the common ratio. So we have that t sub 2 is equal to 5 times 3 over 2 to the power of 1. 3 over 2 to the power of 1 is just 3 halves. So I get that t sub 2 is equal to 15 over 2. And let's think about whether that term is could be, let's think about whether that term could be negative as well. Well, if I had negative 5 times negative 3 halves to the power of 1, well, I would have a negative and a negative, so t sub 2 can only be positive here. And that also follows that if the first term is negative, then, and that means that the common ratio is negative, and the second term would have to be positive. So t sub 3, let's see here. T sub 3 is going to be equivalent to A, which is 5. We'll do the positive case first, and then we can rationalize the other possible value of the third term. So the third term is equal to 5 times 3 halves to the power of 2 minus 1. And let's think about this for a second. Do we really need to use this formula to calculate the next consecutive term, or can we do something that's a little bit easier? So this is where the recursive formula comes into play. We know that for a geometric sequence, the next consecutive term, or sorry, the nth term is just the previous term multiplied by the common ratio. So t sub 3 is going to be equal to t sub 2 times r, which is equal to 15 over 2 times 3 halves, which is equal to 45 over 4. So there's two possibilities here. We have, therefore, the first 3 terms are, we could have the first term and the common ratio both being positive. So we could have that the first term was, let's see, could be 5, 5 and then 15 over 2. And then 45 over 4, or negative 5, negative 15, positive 15 over 2, and then negative 45 over 4. Oh, I missed a factor 4 in the denominator here. So 5, 15 over 2, and 45 over 4, or negative 5, 15 over 2, and then negative 45 over 4. And that's because in this case, the first term is, when we had the first term being negative, the common ratio had to be negative as well. So if the first term is negative 5, then the sign of the next term is going to be flipped. So the sign of the second term will be positive. Then the sign of the third term will be negative again because the common ratio is negative.